So we're working on the problem where we need to maximize the area of a square fencing when we have 100 meters of fencing. So we've set up the equation 100 equals 1x plus 2x plus 1y plus 2y equals 100. So we can also say, based on what we know about squares, that a equals xy. And we can also say that we know perimeter is p equals 2x plus 2y, which is very similar to this right above, because they're exactly the same. So we can now substitute that in. We can say 100 equals 2x plus 2y. Now, if we want to eventually maximize the area, then that means that we're going to need to substitute into that equation to maximize it. So first what we're going to need to do is use this equation to solve for one of the values. So let's solve for y. Or let's solve for x. So we can say 2x equals 100 minus 2y. And then we can just divide all that by 2 and say x equals 50 minus y. Then we can plug that in to our original equation up here and say that a equals y.
So the thing you need to recognize with the fencing is that there are going to be 5 sides of
a equals y 50 minus y.
The thing that you're going to realize is that your first equation is going to be basically...
From there, we can just distribute and say a equals negative y squared plus 50y. And then we can maximize this by solving for the derivative, which would be negative 2y plus 50. From there, we can just find the maximums and minimums by setting it to 0. So we can say 0 equals negative 2y plus 50.
First thing we're going to do is
y equals 25. But now we can't just look at that. We also have to look at when it's 0.
Okay, so first we're going to be plugging in 750.
So we can say 25, 50, which would be 0 for x based on our square up here, and 0. If it was 0, the area would be 0. If it was 25, it would be 25 times 25, which would be 625. And if it was 50, x would be 0, so it would be 0. So 25 is obviously our largest area at 625. So now all we need to do is solve for x. We can say x equals 50 minus 25. X equals 25. Y equals 25. The maximized area is now a equals 625.